Good morning, and welcome to the session that I'm going to be delivering on building a telemetry pipeline with Azure Event Hubs, Azure Service Bus, Azure Stream Analytics, and SignalR. My name's Alan Smith, and it's great to be welcomed back to TechDays in the Netherlands. I've spoken here on a number of occasions over the years, and it's always good to visit. So a bit about myself. My name is Alan Smith. I describe myself as a developer, trainer, mentor, and evangelist. I love building stuff. I love building proof of concepts for customers. I'm currently working on a couple of customer Azure projects, focusing on using a lot of Azure technologies. I'm also a trainer. I've done 3 Pluralsight courses, starting to put together my 4th Pluralsight course. I also deliver a lot of classroom training and custom Azure courses towards customers. I work as a mentor quite often, so I like to go and work with a team of talented .NET developers and help them to get up to speed with the Azure technologies and build great solutions. And I'm also a bit of an evangelist. I've heard that Microsoft doesn't like using that word anymore. I like to promote technologies I believe are going to help companies to be able to build better applications. I work at a company called Active Solution. We're based in Stockholm. I'm also an Azure MVP. I've been an MVP for about 12 years, starting off as a BizTalk MVP. So I come from a very strong messaging, asynchronous messaging, message processing type of background. I'm also a community leader, so I'm involved in something called the Global Azure Bootcamp, which is going to be running worldwide. I'm going to talk about that later on because there's going to be events in the Netherlands that you can attend and learn about Azure. And I also run, together with a friend of mine, the Cloudburst conference in Stockholm, which we've just had last week. So a couple of definitions. First one is telemetry. This is really coming from, or adapted a bit from the Wikipedia definition. So telemetry just derives from a couple of Latin words, tele meaning remote and metri meaning metering. So telemetry is really about gathering or harvesting data or readings, signals or events from devices that are distributed remotely. And then the whole sort of science around telemetry is being able to bring in that data, process that data, aggregate that data and make sense of that data. And the architecture that I'm going to be focusing on today is going to be looking at building something called a telemetry pipeline. I've heard this term used in a number of occasions in many different sessions, many different topics, and it's really the architecture that we're using to build and process this telemetry. I googled for telemetry pipeline and couldn't come up with a great definition for it, so I decided to create my own. And I'd said it was the architecture for ingesting, processing and analyzing telemetry event streams. And it can be comprised of a number of stages and utilize different services. And that's what we're going to focus on today, building a telemetry pipeline. So I'm actually doing 2 presentations today. This one is going to focus on the theory. So I'm going to be talking about the architectures, the services that I'm using, what capabilities those Azure services provide, and how we can connect those together. The second session that I'm delivering this afternoon is going to be focusing on a demo, and that's going to be basically building the actual telemetry pipeline live on stage. That's normally a 60-minute demo, so I'm a bit scared that I've got a 45-minute demo, and hopefully I should be able to get that complete, but it's going to be interesting to watch. So a couple of scenarios where you might want to use telemetry. Game services is a good example. One of the technologies that I'm going to be talking about today is the Azure Service Bus Event Hubs. And the Event Hubs were actually prototyped and built. The sort of pre-release versions were developed during the development of Halo 4. And when Halo 4 went live, they were processing, I think it was something like 150,000 readings per second, events per second that was running through those telemetry streams. And it's up from that. I think they're around 250,000 messages a second on some of these online games. So we need infrastructure that can process that. The types of things they do with the telemetry data, can we provide a better gaming experience? Halo has this, the Halo world that you can use on your devices, on your tablet devices, and be able to follow the games live. Also, are people cheating in the game? Are we getting any people, following bad practices or being abusive? We can monitor telemetry data. How are players playing the game? Can we learn from the way that people drive? If you look at games like Forza, they actually analyze the telemetry data of people who are playing the game and then use that telemetry to help generate better bot cars that can drive in the game and drive more realistically. Industrial automation is really where the money is with telemetry and the Internet of Things. It's not about, wrist devices monitoring your heartbeat. It's about monitoring big, expensive machinery that could be susceptible to vibrations or temperatures or worn-out parts. So they're doing a lot of monitoring, condition monitoring and preventative maintenance as well. You know, can you replace a $10 part on a machine before it causes $1,000 worth of damage to that machine? So they're focusing on preventative maintenance, that type of thing. Vehicle telemetry is also big, with the event of cars being able to be connected to the internet and being able to monitor telemetry data from the vehicles. Taxi companies, delivery companies are going to want to know sort of where their vehicles are. Vehicle manufacturers also being able to report a problem with a vehicle before it's going to run into an expensive problem and be able to make changes and so on. So it's great to be able to monitor that telemetry data. Also with traffic planning, you know, are there any traffics, are there congestions? Could we use the telemetry data from taxis that are driving around the city to be able to route an ambulance around the city if it needs to get to the hospital quickly? Because taxi drivers usually know the quickest ways from A to B through the traffic. So looking at the architecture for telemetry processing, the first thing that we start off with is an event source. The event source is going to be a device. It could be an application running on a phone, it could be a car, it could be a heating system, it could be a weather system. And it's basically something that's going to be generating a stream of telemetry data or readings or events. The next stage that we have is ingestion. And there's a couple of services within Azure that we can use for ingestion. Event Hub is one of the sort of prime services for that. We may choose to have the devices interacting with Event Hub directly. We may choose to have some kind of gateway service, a REST-based service that the applications can interact with, and then that service sends the messages to Event Hubs. I haven't mentioned this on the slide, but there's also lots of developments coming with the Azure and Internet of Things and Intelligent Edge, where they're focused on, a factory. Do you connect all of the devices in the factory to something that's running in the cloud, or do you have something called a field gateway, some kind of system that's going to harvest all of the telemetry data from all of your devices and then broadcast that data to a service that's running in the cloud? So there's plenty of developments. And many of the challenges, if you're looking into working with an Internet of Things project, IoT technology, is this, getting the data from the actual device into the cloud. There's a lot of work that needs to go on there. My focus is going to be mainly from the ingestion stage onwards into the actual processing and visualization. The next stage is being able to process that data. If we're getting in, 150,000 telemetry messages a second, what do we do with that data? How do we process it? How do we ensure that we've got enough processing power to be able to make sense of that data and be able to do a good analytics on it? A few technologies we've got there. We've got a couple of complex event processing technologies. I'll talk about CEP, complex event processing, a bit later on. Azure Stream Analytics and Apache Storm, both very similar for being able to run queries on live data that's running through. We may want to store or archive that data. Azure has a fantastic range of different data storage technologies. We've got traditional relational SQL databases. We've got table storage that allows us to provide sort of really high throughput, really low cost and low latency access to the data, and scales fantastically for large data volumes. We've got blob storage for storing binary files, and we've got Cosmos DB, formerly known as a document DB, for being able to store more structured data. And then the analytics. Power BI is a great tool for analyzing telemetry data, and we can build our own custom visualizations on that so we can gain an understanding. Also, mapping can be used. If you're working with vehicle technology, using a map and being able to show the cars moving around on the map is going to be something that's going to be very beneficial to your projects. So let's take a look at some of the messaging technologies that I'm going to talk about. First one, Service Bus Event Hubs. These are built for event ingestion. They provide something called buffered storage, and I'll talk about the architecture of that a bit later on. They're also massively scalable. I've talked about 200,000 messages a second, but some of the customers using Event Hubs are running up to millions of messages per second. Clemens Vastas, who was speaking here yesterday, he's working and active with the Event Hub, and one thing he's said to customers is there is no limit on the amount of messages per second that we can process. If you want to process 10 million messages a second, we can build that for you. We'll send you a very, very large invoice, but we can create that architecture for you. The Event Hubs are very, very scalable, so really there's massive scalability that we can run that. The next technology that I'm going to be using is Stream Analytics. This is a complex event processing where you can write SQL-based language queries on live data streams and extract values from those data streams. And I'll show you a couple of queries when I actually run through the demo so we can see how that works. The next one is Service Bus Brokered Messaging. This is another technology that Clemens Vastas has been heavily involved with. This provides what I describe as enterprise class messaging functionality. I'm a BizTalk developer, so I like to have things like dead lettering. I like to be able to work with message sessions, work with message expiration, be able to do publish, subscribe, context-based routing, all that type of stuff. Event Hub is built for bringing in large data volumes. It doesn't provide things like dead lettering or routing or publish, subscribe. Service bus brokered messaging does. We have a limitation, though, on each messaging entity of about 2,000 operations per second. So it doesn't go up to these hundreds of thousands of messages per second, but it provides great capabilities, and it's very, very cost effective to use for lower message volumes. Then we've got SignalR. SignalR I'm just using for the visualization demo. I'm not going to talk too much about the technical details of SignalR. Just by coincidence, Clemens Vastas was also involved in the development of the SignalR technologies. But what this is using is a way of being able to push messages out and send messages out to browsers and devices. And it's built into the ASP.NET technology, so you've got access to that from .NET. The scenario that I'm going to be using is a real-time driver tracker. I've got a racing game. If you've seen me presenting before, you may have seen this racing game. And this is going to be sending telemetry data through a telemetry pipeline, some kind of architecture. And we're going to be providing one of these, which is a live driver tracker, which is going to be showing the 3 tracks that we've got in the racing game, and it's going to be showing the players actually going around the tracks in near real time. And we're going to put that architecture together during the session, and I'll be doing that. I'll be demoing that today, this morning, and running through the demo of building that this afternoon. So this is the actual architecture of what I'm going to be creating. We've got the racing game, various instances of that, and they're firing their telemetry data into the Event Hub. This includes things like the steering, the speed, whether you're using the brakes, what gear you're driving in, your X, Y, Z position within the game world. And that gets fired into the Event Hub. We've then got basically 2 streams of telemetry. One is taking the telemetry data, running it through a Stream Analytics query, pushing it into Azure Table Storage, and that's going to be used to generate graphs for telemetry graphs. So if somebody's driving faster than you, you can go into the telemetry graphs and you can see where they're applying the brakes in the various corners as they drive around the track and see what speed they're going. The real-time data is going into another second Stream Analytics query. That's then going into a service bus topic, and we've got web applications that can subscribe to those messages and send them out via SignalR to that driver tracker. This was actually used in the Global Azure Bootcamp in 2017. I'm now on the team that's working on the Global Azure Bootcamp in 2018. Last year we had about 248 locations, I think it was, around the world doing a hands-on day. Has anybody attended one of these Global Azure Bootcamps? So just a couple there. I'd recommend attending in the, 2018. It's going to be on the 21st of April. And if we zoom in on the map, we've got one location in the Netherlands presently. I think last year there was about 4 or 5 different locations in the Netherlands. So hopefully that's going to be accessible. And it's going to be a full day of doing hands-on labs and presentations in Azure. And hopefully we're going to be maybe using the racing game and maybe doing some hands-on lab and hands-on work around that. And that's basically a screenshot from the game, sort of showing the people in different locations who are competing and stuff like that. This is from the actual portal when I was running the lab. So this is the events that are running through, the utilization that I'm running on the telemetry archive job, and then that's showing the Event Hub, the amount of data that was running through the Event Hub. And you can see we got a big sort of pickup in data about 6 o'clock in the morning. I had an early start when the event started kicking off in Asia. So let's focus on the event source. The event source is basically going to be the driving game. The driving game is going to be sending its telemetry data directly into the Event Hub. The ingestion stage, we're going to be focusing on using the Event Hub to be able to actually take in and ingest that data and provide a buffered storage of that data. So as I mentioned, the Azure Event Hubs, they're built for ingestion, they provide buffered storage, and they're massively scalable. I haven't talked too much about the buffered storage, though. So basically, the Event Hub is different from the way we have what we think of when we think of a typical queue. When we're dealing with a queue, we send messages to the queue, and people will receive and delete those messages from a queue. So once a message is received and processed, that message is typically deleted. In the Event Hub, the events basically build up in something called a buffer. And if we create an Event Hub, we may have a 24-hour buffer and or a 7-day buffer, depending on how we've configured our Event Hub and how that data is stored. When you generate a Stream Analytics query to listen to that data, it will basically have a cursor on that buffer. And as the data comes in, the cursor will move along and hopefully keep up with the data that's going into the buffer. Now, it depends on the processing speed of your receiving application. You could get 1,000 messages coming in and you can only process 500 of them. But assuming that you can keep up with that buffer, the cursor will just basically work its way down the buffer. But the data is not deleted. That's one important concept. So if we decide maybe a few hours later to add on an archiving job, we've got the option. We can say, OK, start this job at datetime.utc now, so it will go to the end of the buffer. Or we can say, start the job from the event data from an hour ago or 24 hours ago. And it will basically start its cursor there within the event buffer and go on and catch up with the actual data. So it's a very different way of being able to work with queues. Also, if this was a queue, each message that you sent to the queue would be received by just one of the receivers. You have this competing consumers pattern. So you send in 1,000 messages, maybe 500 would go to one job, 500 would go to the other job, which is great if you're in a load balancing scenario. But here, we want all of the jobs to process all of the data. So if you send an event, the telemetry analytics will process it and the telemetry archiving will process it. So that's quite different to the concept of a queue. So looking at the processing stage is going to be using a technology called Stream Analytics. I was in the presentation before. I couldn't understand a word of it, but I could understand things like, I could understand a few words like Stream Analytics kept popping up. And Stream Analytics is basically a different way of thinking when you're thinking about working with data streams. Typically, with big data scenarios, you're thinking about selecting data from a large data set. So basically, you've got a large data set. This can be sharded. This can be distributed across multiple databases. It could be a data warehouse. It could be Hadoop, that type of thing. But when you want to extract value from that data, you're typically saying select a value from a static data set. This is what we do, what we think of. We start off learning this with technologies like SQL Server. And as the data volumes get larger, the queries take longer to run. So you'd end up with, going for things like, SQL Data Warehouse and various customer cases where they've been having queries, analytics queries on their business data that take about 8 hours to run. And they're saying, we've got this query down from 8 hours to 20 minutes to actually produce this report on the big data volumes. And that's the type of things we kind of think with big data, optimizing these big queries and doing all of these partitionings and indexes and all types of stuff like that. With event processing, we basically make the assumption that the data size is infinite. We're not interested in the data volume. We're not interested in how many gigabytes of data there are. What we are interested in is just processing a stream of data. Think about Twitter. There's a couple of ways of being able to analyze Twitter. If you're a company and you basically a large coffee chain, maybe Starbucks, you're interested in, what do people think about my company? Well, you can go in and you can start querying the static data within Twitter. And you can say, what have people, tweeted about my company? What have people said about my company? But what may be more important is what people are saying about my company. What is the current mood, the current focus? So you're not really interested in querying all the stuff that has previously gone. You're interested in what people are currently tweeting. So it's a big business, companies that are doing like these media analytics, social media analytics, to analyze the actual streams and say, what are people saying about my company? And then having people who can react to that and be able to engage with customers. So the idea here is that we're selecting value from a dynamic data stream. We're querying this live data. And this is really what complex event processing is. So why would we want to use this? I travel around and speak at a few presentations. I spoke at a presentation in the south of Sweden, and 2 days later, I got a phone call from my bank saying somebody has actually tried saying my credit card had actually been used to try to pay for a taxi in New York. And I was thinking, well, why did that happen? Maybe I was down somewhere, I used my credit card and somebody had cloned that credit card and then somebody's using a copy of that credit card in New York. How did they know? Well, monitoring the credit card transactions, they can basically say, okay, well, everything's as normal. Alan's going around Stockholm doing various things, and he's suddenly in New York booking a taxi. But yesterday he was in Stockholm. That's something that's out of the ordinary. So being able to react to these kinds of events, these transactions that are out in the ordinary, that can raise a flag somewhere, and they can basically go in and take some human action to be able to, ring me up and say, is this a fraudulent transaction? And that saves the banks a lot of money, how accurately they can detect those fraud detections. Stock trading, obviously monitoring the trades on stocks and being able to react very, very quickly to what is happening now. Why are people buying? Why are people selling? How is the market changing at this second? Rather than, what were the trends over the past 6 months or the past 2 days for that particular stock. Lots of money to be made there as well. And also the vehicle telemetry analysis. How can we monitor for traffic congestion based on the real-time data that's coming in from various vehicles that are traveling around? You see this on Google. I take my kids swimming a lot, and whenever I go to look at the swimming pool, there's a graph on Google saying how busy the swimming pool is, which is presumably coming from telemetry data from people on mobile devices who are traveling around. They can tell how many people are at a particular location and be able to say, how busy a shopping center is, how busy a sports center is, based on analyzing that type of telemetry. So the technology that we're going to be using for this is the Azure Stream Analytics. Azure Stream Analytics is basically provides capabilities for something called complex event processing, and it allows us to run queries on live data streams. The great thing for us as developers is that the query language is very much like SQL. So if you can query a SQL database, you can query on Stream Analytics. It's designed to work that way. So people who are interested in working with data queries, it's a very low learning curve to actually get onto working with Azure Stream Analytics. So Azure Stream Analytics integrates very well with other Azure services. Normally when you're connecting things together, you've got to deal with connection strings, you've got to write code to be able to get data from one place to another. Stream Analytics provides great integration with other services. So as our inputs, we can use a data stream, we can use event hubs, or we can use a binary file containing data in blob storage, which can be treated as event stream. We can also cross-reference that with static data. Static data can be in blob storage. So if you're basically getting a bunch of vehicle telemetry data, and it basically has the actual, the device ID, and it has the actual other telemetry data, such as the speed, you could have another table in blob storage that links the device ID to the actual vehicle number and the vehicle details. So that could give you a query that gives out the vehicle details and the current speed by doing that cross-referencing of static data. And you can use multiple data references in your queries. It's very versatile in the outputs. We can send the output events to another event hub. We can send it to a service bus queue. We can send it to a service bus topic. That's if we're focused on doing messaging. If we're focused on archiving the data, it can go into blob storage, it can go into table storage, SQL database, or into Cosmos DB, formerly known as a document DB. And we can also, if we want to, send it directly to Power BI. I wouldn't recommend doing that. It's okay to do a nice demo to show, telemetry data and maps appearing, but I would, definitely focus on pushing it into a static data store and then using Power BI to access the data from that static data store. But the capability is there if you do want to go directly to a Power BI workspace. So this is what a Stream Analytics query looks like. I'm selecting the average speed where it exceeds 100 miles an hour in a 10-second sliding window. So if this was vehicle telemetry, it would be used to issue speeding tickets. It basically say, okay, the cars are driving, faster than a certain speed, faster than they're allowed to drive, across a certain time window. Insurance companies, I don't know if this is the same in the Netherlands, but insurance companies in Sweden, you can get a box put in your car, and if you are a safe driver, you will get a lower premium on the insurance by monitoring the actual telemetry data. I use this the other way around. I use this for giving achievements in the driving game. So if you drive fast and you basically fulfill this criteria, you've got an average speed of greater than 100 kilometers an hour for a duration of 10 seconds. Then it basically sends an output message, and you get an achievement for your actual global Azure Bootcamp application. And there's a number of achievements that you can go in and fight for. The thing that makes this query different is a group by clause. I'm grouping by a sliding 10-second window. So that's really the only new thing that you've got to consider if you're a SQL developer who's moving on to Stream Analytics. So let's have a look at the different window types. We've got 3 different types of windows. The sliding window basically runs like this. It doesn't have a definite beginning, it doesn't have a definite end. But what it's saying is that if at any time, any 10-second period, the average speed was greater than 100 kilometers an hour, then it's going to trigger an output event. Next up is the tumbling window. So if you've got a tumbling window of 10 minutes, this is going to give you the average speed over that 10-minute period, or average temperature if you're monitoring temperature devices. So this is typically used when you've got a high volume data stream coming in. You've got a temperature sensor that's sending you a reading per second, and you want to average out that reading per second into one reading per hour and store that down into data storage. And also maybe bring in the maximum and the minimum temperature within that time range. That's when you could use a tumbling window. Tumbling window doesn't give you that much precision, because if it was, for speeding, you could have a big burst of speed where the average speed is 60 kilometers an hour in this one and this one. But you did have a period when you're traveling at 100 kilometers an hour, but it was overlapped between two of these windows. So it doesn't really register in the averages, in the other averages. So then you've got the option of using a hopping window. You could set this to have a 1-hour duration and a 10-minute hopping interval. So every 10 minutes, it will give you the average temperature from the previous hour. So you can basically combine these window types in your queries. So looking at the, I'll just give you a demo and show you the actual query that I'm using in the Stream Analytics. So I've got my stuff provisioned in Azure. This is my resource group, which I created about 15 minutes ago, and it's called TechDays. And I've got a couple of Stream Analytics jobs, and the driver tracker Stream Analytics job is here. So this is the input. I've got the input configured to connect to an event hub. So this is coming here, how we actually configure these inputs. It's connected to an event hub within my service bus namespace. If I go to the outputs, this is configured to send the output messages to a topic, and the topic name is Telemetry, and I'm within the TechNL-SB service bus namespace. We've got various formatting options, JSON, UTF-8, line separated, specified here. You've got, I don't think I can change these. No, these are basically locked, but you've got options of using various different formats, CSV, and also, I can't remember the name of the other, there's another format that you can use that is more typically used in Apache Storm. This is the actual query that I'm running. It's appearing a bit grayed out because I'll actually paste it into the other query window so we can see it a bit more clearly. So if I go back here to this, the archive, which I haven't configured, and just drop in the query. This is the query that I am specifying here. So I'll see if I can zoom in a bit on that. Yeah, that's a bit better. So what I'm doing here, this is the actual telemetry data that I'm pulling out. I'm selecting the driver, the country code, average speed, and then I'm interested in the position, because this is a driver tracker going on a map. So I'm selecting the X and the Y coordinates. We also have the Z coordinates, which is how high up you are, but that's not important for a top-down driver tracker. I then get a bit of the actual driver input telemetry, the accelerator, the brakes, the ERS battery that I'm simulating, and also the lap time in milliseconds, how far we are around the lap. Now I'm specifying into driver tracker, which is the output from telemetry, timestamp by event time. This means that when you're calculating your time window basically has a beginning and an end. By default, the time is going to be the actual time when the event is processed. Now, if you want to run this query on data starting earlier, so you've got an hour's telemetry data and you want to start the cursor and run across the previous hour, timestamping by datetime.utc.now isn't going to work, because all the data is going to be ingested at exactly the same time. So everything will go in the same window. So timestamp by event time means we actually take the event time date time stamp that we've got in the telemetry data and use that to calculate how the data fits into the windows. And that means that we can run on events that come in late. If the event comes in a few minutes late, then it's going to be placed in the appropriate window. I had to add this where clause actually during the Global Azure Bootcamp. There's one driver who started driving a lap in the racing game, and then they just stopped and walked away, and they left the car on the middle of the track doing nothing. So it was basically generating this stream of telemetry data. And we had this car that was just sat there all day on the actual driver tracker. So by putting in that query, where the lap time in milliseconds is less than about 6 minutes, then that car disappeared. Anybody who's been driving for longer than 6 minutes doesn't get included on the actual driver tracker there. Then I'm grouping it by country code driver, and then I'm using a tumbling window of 1 second. Now, the reason I'm doing that is the website is basically getting these events coming from SignalR, and I want to be sending out about 1 telemetry event per second out to SignalR. However, the driving game has, the event hub to send its telemetry data to, so we can send in, if it's running at 50 frames a second, we could be sending in 50, input data, input messages per second. But sending out 50 events through SignalR to the web pages is basically going to break the web application. So there we're able to average things out and sort of filter this telemetry data down to once a second based on the average values. So that's not too complex to build that type of query. Just see quickly the outputs. I'll just discard that and. In the output configuration, I will be doing this in the demo session later on, but when I choose the sync, we can see that we've got all of these different technologies that we can go to. A couple I haven't mentioned, like Azure Functions as well, is coming out. So if you're playing around with Azure Functions, you can send the data off to one of those. Data Lake as well, we've got present there, and I think the other ones I've mentioned on the slides. So very easy to configure these. There's virtually no code to actually get the integrations to work. Okay, service bus brokered messaging. This, as I mentioned, provides the enterprise class messaging functionality. So it gives you dead lettering, it gives you publish subscribe using topics and queues. You can do context-based routing, you can have message expiring, you can have scheduled in queue time, all that type of stuff when you want to do a bit more sophisticated stuff with messaging. It is very cost effective, so I think it costs you about $8 per month once you activate a service bus namespace in your Azure account, and then you get about 1 million messages per month to actually send through that. And then you pay, I think it's something like $1 per million message operations. It's very, very inexpensive to be able to run messaging through these. So when you're looking at the costs that you've got on the Azure resources that you're consuming, you've got things like your virtual machines, your web apps, your SQL databases, your document DBs, Cosmos DBs, and all this type of stuff at the top. And pretty much at the bottom of the list, if you sort by price, you've got the stuff that you've consumed on the Azure Service Bus, which can be just a few dollars per month, a few euro per month on the actual Azure projects. So this is very inexpensive technology to use. You've got up to 2,000 message operations per second. Now this is what's known as a scalability target. It means that it should be able to give 2,000 messages per second on a good day. However, it's not a guarantee. It's not a service level agreement, so you can't guarantee that you'll be having 2,000 message operations per second. If you want guaranteed performance, you can pay more money and you can go to the premium account on the Service Bus brokered messaging tier. That's quite a lot more expensive, but it does give you a guarantee of performance. What it does is it basically provisions your own infrastructure for running the service bus. So you're not sharing that with what people in cloud computing call noisy neighbors. Somebody on the using the same infrastructure as you sends a huge burst of messages, and that may negatively affect your performance for a few seconds. So by having your own infrastructure, you can get guaranteed performance. However, sometimes that guaranteed performance will be a bit less than the performance that you'll get on the actual regular tier. But it is guaranteed, and you can scale up the performance by provisioning more resources on the premium tier. So the types of messages that we've got a queue, which is a standard queue for first in, first out queue. And we've these things called topics and subscriptions. This is what gives us the publish subscribe architecture. For every message that is sent to a topic, a copy of that message can be sent to the subscriptions. Now, there can be filter rules on this, so you can filter to messages where the priority is equal to high, or where the message type is equal to order, or where the message type is equal to test, or message type isn't equal to test. You can build these subscription filters. By default, when you generate a subscription, it will subscribe to all of the messages. Behind the scenes, it has a subscription filter that says if 1 is equal to 1, then subscribe to that message, and that subscription filter is created by default. So if we have a topic, every time we generate a subscription, we will be subscribing to messages. And this is what I've used, the publish subscribe architecture, to be able to get the messages out to the actual driver trackers that are going to be running. During the Global Azure Bootcamp, the hands-on lab that I created that went along with the racing game was to build your own driver tracker. So you basically went into Visual Studio, you started with a website template, and you basically wrote code to receive and process these messages. So when your website starts up, the first thing it did was it created its own subscription in a service bus topic. There is a limit here. You can generate up to 2,000 subscriptions in each topic, but you can chain topics and subscriptions together if you want to broadcast to more receivers. So I kind of thought, well, there's not going to be more than 2,000 people running the actual lab at the same time. At least I hope there's not going to be more than 2,000. Otherwise, it's going to fail on creating the topics. But that's basically what we did. So I'm sending these 1 messages a second. You've seen the query that was doing that in Stream Analytics, and they're basically being sent to that topic. Each website instance has its own subscription. So each telemetry message that comes in gets broadcast out to all of the actual websites that are going to be actually hosting this driver tracker. And in turn, using SignalR, they'll be broadcast out to all of the actual browsers. So that's how I'm using the pub sub. So looking at the analytics stage of things, using SignalR. SignalR is basically scalable client-server messaging. If you think about it as another layer of publish, subscribe, it allows me to actually broadcast out to multiple devices. So my first layer of publish subscribe is the telemetry data from the racing game is being sent to a topic. And the people who build the driver tracker website, they subscribe to those messages, and each website that's running the driver tracker lab will get a copy of those messages. Now, there's going to be multiple browsers that are viewing that are actually viewing the page on that website, and the SignalR is used to actually communicate and push out the telemetry data, 1 message per second, out to the actual people who are browsing that particular website. So we've got a couple layers of publish subscribe going on. It does have cross-platform client compatibility, so we're working with JavaScript on the client side to be able to actually hook up and process those messages and be able to provide the visualization on the analytics. So a review of the architecture of what we've built. We've got the game, we've got the stuff going into the event hub, the events, and you've seen this Stream Analytics query. This is the one I showed you where I'm selecting the telemetry data, averaging everything out over a tumbling window of 1 second. So we're getting 1 message a second going into the service bus. The part that I haven't shown yet is the web application subscribing to the service bus and showing stuff on the driver tracker. And I've got about 5 minutes left, so I can probably just about run through that particular demo there. So this is the actual code for the racing game. The racing game started out life as something called XNA Racer. It was basically years ago, Microsoft had a game development technology called XNA. XNA was an add-in for Visual Studio, and so there's a developer community around XNA. And one of the games that Microsoft actually developed as a sort of demo application for XNA was the XNA Racer. So I started out with this XNA Racer game, and I originally used it in my first Pluralsight course to I integrated the game with Azure Storage, and I'm storing like the ghost cars, the replay data for the ghost cars is stored in blob storage. The high scores and lap times are all stored in table storage. And I've spent an unhealthy amount of time sitting and hacking and processing and modifying and changing this game. I modified a lot of the tracks. I've rewritten quite a bit of the physics engine, which has got nothing to do with Azure, but that's good fun. I've done some work on the graphics as well and stuff. So you basically see, if you've seen the original game, you'll see the changes that I've made. The important part here is what I'm doing with the actual telemetry data. So we've got this class here, which is called Event Hub Telemetry Sender. I'm doing some stuff, and what I'm basically doing is sending event data out to the Event Hub. So I'm creating this event data here. I'm taking the telemetry reading here, which comes in. I'm converting this into JSON. I'm then taking the bytes from that string and sticking that into the event data class. And then I'm using the Event Hub client to actually send this data asynchronously. So that's just firing off the stuff to the Event Hub. The receiving and processing application here, I'll just stop this because it was running in debugger. This is listening to the service bus. So this class represents the driver telemetry that we're getting, and then I've got this code here, which is just going to dequeue and process the messages, and it basically does clients.all.broadcast telemetry and fires this out to the clients using the SignalR stuff. So if you work with SignalR, this isn't really rocket science. So what I'm going to do is to start the driver tracker application in debug mode. What this is going to do is it's going to pop up and display this. It's just an image which basically shows the layout of the tracks. What also should have happened if I go back to the portal and go into the service bus, and this was this thing here, and I should have a topic which is called telemetry. And within the topic, I should have a couple of subscriptions that have been created. Now, subscriptions, when you create a subscription, you can set a property called auto delete on idle, and you can set that to 10 minutes. So when somebody shuts down the website after 10 minutes, that subscription will disappear. I've got two subscriptions. One of them was when I was from previously running it in debug mode, and one of them from the actual new instance that I've created. So this subscription, I'm using a globally unique identifier as the name, so I don't get any name clashes. It will subscribe to all of the messages, and they will be broadcast out to the actual website itself. So what I've got to do to demo this is to bring on the actual web page, which is this thing here, and then I need to start an instance of the driving game, which is this thing here. And this is going to take a few seconds to start up. What I will also need is an actual event key. When we were running this Global Azure Bootcamp, you had an event key. I'm actually going to take one from the Netherlands and just copy this. This is the data that I was using for last year. So if I just do Control-C to copy that, bring up the web browser and go to the racing game. So the racing game is asking me to enter a lab key. So I'll basically paste in this and click on Select. And you can see sort of behind here what's going on is these are basically all the ghost cars, the ghost car data from previous years. I'm basically simulating them driving around the actual lap. I can then go on a start race, and I mentioned about playing around with the graphics. I took all of the event locations and then basically mapped them into all of the flags, and then took the flags for each country and wrapped the flags around the cars as the actual graphics. So when you're playing this game, you get the actual flag from your particular country customized on your car, and when you see all of the other cars, they'll have all of the other country flags. So it's great if there's any rivalry between countries. You can be, chasing and hunting down a flag from your rivals. I'll put in Alan as the actual driver name. And what we should see, the easy track is the green track here, which is running around. So you should see Alan appearing on the green track with the Netherlands flag, if anything is working. Now, I'm probably going to suck at driving on this, especially when I'm trying to talk and drive at the same time. So you should see the ghost cars pretty much get ahead of me, and I end up in 50th or 60th place by the time I get to the first checkpoint. But what you can see is Alan has appeared on the driver tracker, and you can see how real time it is. You can see the corner, and you can see I'm going around the corner now, and you can see sort of when the actual mark on the driver tracker goes around the corner. So it's not exactly real time, but there's a couple of lags, maybe a couple of seconds, a second or two's lag in this. But when we were running this in the event, it was fun to see about 30 or 40 actual spots, going around and chasing each other with all the different names and all the different countries appearing, running around on that map. So we may be doing something similar with this at the Global Azure Bootcamp this year, and there will be events in the Netherlands. So please sign up for that and come along, and you're going to be learning a lot about Azure. So I'm just going to round off by just mentioning the capabilities of the technologies and a bit about when to use them. Service Bus Event Hubs, that's what you're going to be using for ingestion. It can work with REST-based protocols, REST-based endpoints, and it is massively scalable. It's not cheap, so you do pay, per hour to have one of these event hubs running. So, don't create it and then leave it running for 2 weeks in your own personal Azure account. You're going to get a bill for that. Stream Analytics, very easy and very low learning curve to get into working with streaming analytics for processing the data. If you can write a SQL query, you can write a Stream Analytics query. And it's so easy to integrate it with the other Azure technologies and start creating event processing. Then we've got the Service Hub brokered messaging. That provides more enterprise class functionality, a lot less expensive, but you do have this cap on about 2,000 message operations per second on the service entities. And finally, SignalR, not really an Azure technology, but great for being able to push and send messages out to browsers and so on. So thanks very much for listening. My name's Alan Smith. The next session that I'm going to be delivering in the afternoon is going to be hands-on, and I'm going to be it's going to be minimal PowerPoint slides. I'm actually going to be hopefully building that whole telemetry pipeline. As I mentioned previously, that was a 60-minute demo, and it was quite hard to do it in 60 minutes. So I've got this little clock thing ticking down. It's going to be going down from 45 minutes this time. It's going to be interesting to see if I can do that. So if you want to see if I can do that, or if you do have any questions, feel free to hang around and chat at the end of the session. Thank you very much for listening.